Okay, so how can we define cephalosporin? Cephalosporin are the group of, again, the group of antibiotics obtained from molds, okay, acrimonium, okay, which was also known as cephalosporinium once upon a time. Now it is known as acrimonium. Now, as you know, we have discussed in our penicillin video, the 6-aminopenicillinic acid, 6-APA, is very important for the synthesis of all the penicillin analog. Similarly, we have 7-amino cephalosporinic acid for synthesis of various derivative of cephalosporin. So what is the structure of that? If you see, the structure is with a 7-member ring, total 8 members, sorry, because it's 7 amino. So this is sulfur, cephin, double bond. This is an amino group, okay, and over here you have a COH, and if you add this functional group, then it become 7-amino cephalosporinic acid. And this was first obtained from hydrolysis of cephalosporin C. Hydrolysis of, it's a natural cephalosporin, that is cephalosporin C. Cephalosporin C. Okay. So this is the cephalosporin, the basic structure, 7-amino cephalosporin. So why this 7? Because 1, 2, 3, 4, 5, 6, 7. Okay. Now if you see, this is not heptane, it is octane, and it is 5-thia, 1 as a bicyclo, in bracket we have to write, it is 1, 2, 3, 4. So 4, 1, 2, 2, 0 octane. Okay. So this is the only difference. And now after this cephalosporin, this basic structure, let us go ahead with the SAR of cephalosporin. Okay, SAR. Now the first thing is, cephalosporin is more resistant to beta lactamase, okay, than penicillin. That I have already discussed. I have already told beta lactamase resistance. So please refer to our earlier video, resistance, okay. And then we have the first generation of cephalosporin. So whenever we are attaching this particular functional group over here, similar fashion, CO and the R. Okay. Now in regular penicillin, we go for 2 substitution. One is R1 and another is R2. So this is R1 and this is R2. Okay. So let us see the different varieties of cephalosporin. Now the first generation of cephalosporin, okay, they are more gram-positive active and they are more resistant to beta lactamase. Okay, so what are the examples? Now if you consider R1 is equal to CS3, okay, and R2 is equal to your hydroxy group with benzene with alpha amine group. Now if you see, this is the same side chain of amoxicillin. Okay, now in the last class in amoxicillin, if you remember, there is 3 type of functional group. One is hydroxy group, one is NH2 group, and one is for carboxylic group over here in case of amoxicillin. Okay, sorry, over here means it is 5-member ring. Okay, So I'll not write. Okay. So in amoxicillin we have 3 ionizable group. So sometimes in GPAT they ask the pK value of amoxicillin. Okay. So what are the pK value? So if you see carefully, there are one extremely acidic, that is 2.6 pK. One is intermediate, that is around your 9.6, and this is amine, which is around 7.49. 7.49. Okay. So similarly in cephalosporin, these same structures are present in the drug known as cephadroxil. This is cephadroxil. Cephadroxil. Okay. If you remove this NH2 group, okay, that time it's known as cephalexin. Cephalexin. So this is the only difference. So this is orally active penicillin, first generation. Now the thing is, then second, the first generation, the next example, I'll continue with more water soluble cephalosporin, which can be given parenterally. Now you have heard carbanicillin in our penicillin section. Carbanicillin is having 2 carboxylic acids, so that's why it is more you can say water soluble and given intravenously. Similarly, we have an IV cephalosporin. So first example is cefazolin, and cefalothin. Okay. So I just discussed the structure of cefazolin. The cefazolin structure is nothing but when R1, the R1 is having the CH2 and the heterocyclic ring, it is 2 nitrogen, 1 sulfur, okay, thiadiazole, okay, this structure with a